Blessings to you, friends. In this video, we're going to be going over how to decrypt data. One way to decrypt data in Linux. Let's just go ahead and jump right into it. In this scenario, we must decrypt encrypted data. This is something that we might do as a cybersecurity analyst or a cybersecurity engineer, just part of the day-to-day job. While working with private information as a cybersecurity analyst, decrypting data is part of ensuring that your organization has access to pertinent information. So, task 1. What we would do here is first within our current working directory, we'd find where we are in our current working directory. We'd find ourselves in the right directory and then discover the files it holds. We can do this with the ls command. So the ls command would spit out the directory contents. Here we have 2 files, and Caesar is a directory. So the command semantics here look like ls. This command provides a full list of files contained in the current work directory minus the hidden files. Note, in conjunction with ls, so you can do ls space dash, you can use the commands l and a. That would look like ls space dash l or dash a or dash la to list hidden files and additional information about the files, respectively. Task 2. In this step, we attempt to discover the information found within the readme text, readme.txt file, that we discovered using the ls command. So the way that we do this is with our cat command. Cat means concatenate. This command accesses the text in the file and it prints it directly to your CLI. Cat, the command semantics looks like cat space and then your file name. So here we've got cat readme.txt, that is case sensitive, and then here we have the readme file. Hello, all of your data has been encrypted. All right, so if we want to read the readme, we need to decrypt it. Task 3. Navigate to the Caesar directory. So CD stands for change directory. Caesar is the name of the directory that we want to change to, and we are in a directory currently where Caesar is. So you need to be in the directory or you need to specify the full file path. CD space directory name. This command changes directories. In this case, from the analyst directory to the Caesar directory. Next, discover the contents of the Caesar directory. Do you remember the command for discovering the contents? If you guessed ls, then you are right on target. ls space dash a. This command lists all the files and hidden files in the directory. So the dash a gives us the hidden files. If it were dash l, it would also give us more information about each file. So ls lists the files, dash a. The A operator discovers the hidden files. Task 5. Discover the contents of the .left-shift-3 file. So do you remember the command for discovering the contents of the file? That's right, cat, which stands for concatenate. Cat space, and then the file name. The cat command opens the text contents of the file. Note the contents of the files are in ciphertext. So we're going to have to decipher the ciphered text. Task. Ooh. I think this is task 6 here. Oh no, it's... Okay, this is task 6A. Here's our command. Cat. And then we've got our file name. Space pipe, space tr, and then here are 2 strings, right? What do those 2 strings do? Let's find out together. The command to the left side of the pipe remains the same. Concatenate this file. The pipe sends the results of the first command. Here's our first command before the pipe. And then the pipe says, send this command into this command. Sends the results of the first command into the command on the right side of the pipe. I do not fully understand yet the command to the right of the pipe. It was provided in the lab. So this is me writing up my task report. Here is what I do know. The TR command is a deciphering command, while the commands within the quotations, here are the commands within the quotations, are instructions on how to translate the text. Furthermore, we can also provide the understanding that hot wings are delicious. We all know that much, don't we? All right. So here's our text that we're trying to decipher. And here is the cipher that we need somehow. I still don't fully understand what this means, but I do know that this is how that works. So task 6. The previous task gave us the information we need to decipher the text in a file we are working with. Seeing that the file is in our home directory and we are currently in the Caesar directory, we need to navigate to the home directory, or the analyst directory is what we're actually in. That's the home directory for the lab environment that I was in when I was going through this lab. Command semantics. So CD, do you remember what that means? That's right, change directory space, and then our, why am I forgetting the name of this right now? I think it's ampersand. That might be ampersand. I don't think that's an ampersand. Anyway, shift, and then the key to the left of the 1 gives you that character. The CD command changes directories. That is not an ampersand. An ampersand is the AND character. I'm blanking on what this is called. This thing that kind of looks a little bit like a hot wing indicates to the computer that we are to be in the home directory. So this means home. Task 7. So we've just changed directories to the home directory, and now we want to decrypt a file using the information that was previously deciphered, because the reason that we changed to this directory is because we want to decrypt a file that's in this directory. Okay, so again, I don't fully understand this, but I do know enough to know that this is ciphering some text. I do not completely understand this command either. Here's an overview of what it do. The command takes the encrypted data from the file after the in command and makes a new file. Kind of key. It's not just deciphering, it's making a new file with a ciphered text in it. A new file with a new name commanded after the out command, right? So here we have the command openssl, and then we have this here is, it looks like this is probably something to do with the deciphering. Maybe it has something to do with SHA-256 dash, whatever this means, dash A dash D dash in. So in, this is a part that we do understand. The in is the telling it in this particular file. So we want to do these commands in this file, and then output what these commands do to this file as Q1 encrypted, no, Q1 dot recovered, dash K, and then that there. So there's your command for that. You can put that in the description box if you'd like, and all you have to do is plug in your in file and out file, so long as your Linux environment supports these particular commands. The command indicates the various attributes of the encryption, such as the algorithm to be used to solve the encryption data, which I'm guessing is probably SHA-256. Okay, command semantics. Here we go. So I don't fully understand it, but here are the command semantics if you want to know a little bit more about it. If not, skip to the next task. The following is mostly a copy and paste from the lab's explanation of the attributes of this command. These commands, I'm not going to pretend like I have a deep understanding of it, but let's go over it together. We can learn about this together. If you expect every one of your teachers to know everything, then you're expecting every one of your teachers to pretend like they know everything, because everybody is truly always learning. So give me some slack and send me some hot wings. openssl. This command reverses the encryption of the file with a secure symmetric cipher. AES-256-CBC indicates the symmetric cipher to be used. -PBKDF2 option is used to add extra security to the key. The -A indicates the desired encoding for the output. The -D indicates decrypting. So this is the one that's saying, hey, decrypt it, I think. -in specifies the input file. -out specifies the output file. -k specifies the password. Ooh. So -k so e to brute, or whatever that weird word is. That is the password to tell the file, hey, the person that's trying to decipher this knows the password and should be okay. But as we're learning nowadays, passwords have largely failed at their job. Okay, task 8. Now we discover the file. So we've decrypted it, we hope, and now it's time to read the file that has been provided by our decryption command. So this is what this looks like. We ls, so we discover what is in our directory, and now we have the q1.recovered file. So now we concatenate the q1.recovered file. If you are able to read this, then you have successfully decrypted the classic cipher text. You recovered the encryption key that was used to encrypt this file. Great work. Good job, guys. You did a great job. Pat yourselves on the back. Have yourselves some hot wings. Command semantics. ls. Okay, ls. This command lists the files and directories in the current working directory. Cat q1.recovered. You guys know this by now. This command provides us with the contents. It concatenates the contents of the particular file that we're after. So that was the home stretch, friends. That's the end of it. I hope that helped you to recognize how to decrypt a file, and I hope that for potential employers, it shows that I at least know enough to decrypt a file and get it in front of the eyes of the people who need to see it, even if I may not fully understand each of the command semantics. In this lab, we navigate our CLI to find various files and directories needed to decrypt the contents of a file. In the end, what did we get? We got a digital attaboy from the recovered or decrypted file. The real question, though, is it possible yet that hot wings can be delivered digitally? Because I think that's what we should have. All right, friends. Make sure that as a cybersecurity engineer, you have got your finger on the pulse of your organization. Keep an eye on what's going on. Don't be asleep at the wheel. And if you're pen testing and hacking, red teaming it up, my friends, hack with love, not with hate. Keep people safe with the skills that you have. That, my friend, that is worth something. Even though it's doing great things is built on one mundane task after another, if you have the right heart behind it, that is what gives you your value. That is what puts you in a place where you are, every day, doing meaningful work. Not just talking about wanting to do meaningful work, but actually doing meaningful work. If you're doing meaningful work and you're hacking with love, not with hate, and you've got your finger on the pulse of your organization, keep up the good work. You deserve some hot wings. All right. God bless the work of your hands, and we will see you in the next video.